In order to tell if you can use the mean value theorem, the first thing is, do we know that this function is continuous in that interval? Now, to tell, I say that it's continuous when values are less than or equal to 3. The reason for that is a square root. You can have zeros and positives. You're not allowed negatives because those would create imaginaries. So what's inside of here can be less than or equal to 3 to keep this being 0 or positive. Now, so that is where it's continuous. And for the interval, -1 to 3, closed, is continuous. Those values fit the interval. So that stipulation is okie dokie. The second stipulation is that is it differentiable on the open interval. So we take the derivative of this, make sure you understand it's a chain rule, so 1/2 power, take a 1/2 out front, drop it by 1, leave the inside, derive the inside. And when we simplify this, then we look at this and say, okay, is this differentiable on the open interval, meaning from -1 to 3, not including the edges, is it differentiable, or the derivatives? Well, basically, you just got to look at this and say, of the derivative, can I plug any value on this interval? And so you look at this again and go, okay, well, on this interval, all right, you need what's inside here to be positive, because otherwise negatives create imaginaries, but you also cannot have this in here being 0, because if this was a 0, you create a 0 in the denominator, causing an error. So basically, your values would be, values less than 3 would be okay, because anything greater than 3 would create a negative or a 0 inside of here. Now, we don't have less than or equal to, it's just less than, because again, 3 would create a 0, which would cause an error. But, once again, for mean value theorem, it has to be differentiable on the open interval. And 3 is the edge, so we don't have to have 3 differentiable. Alright, so we are okay differentiable on the open interval. We're good. Alright, so it's continuous on the closed, differentiable on the open. We're good. Stipulations are set. So now what we got to do is find the slope on the two edge points. So of the secant line going through these 2 points, I want to find the slope of the secant line. So to find the secant line, I plug in -1 and 3 to the function. That's what I did here and here. And I get 2 and 0. So I have a coordinate, -1, 2. And I have a coordinate, 3, 0. Those are my coordinates. I now find the slope for this coordinate. And I get -1/2. So the slope of this graph on this interval, the two edges, the secant line, slope is -1/2. Next, I need to set the derivative, here in green, equal to the slope. I'm trying to find out where does my slope of my function equal the average slope of the function, because -1/2 is the secant, the average slope. So I set the derivative equal to -1/2, and I solve this. Now what I did is I cross multiplied here. So -1 times 2 is -2. This times -1 is -2 square root 3 minus x. And now I'm solving what's in the blue, so I divide by -2 both sides. And I come up here. All right, then I square both sides. Then I minus the 3 over and divide by -1, and I get 2. What does that mean? Well, at 2, which is on the interval, I will have a slope of -1/2, which is equal to the average that goes through the two edge points. All right, that's mean value theorem. You want to find a point on the interval that has the average slope of the secant line. And that is the point. And these stipulations in front tell me that I actually can go on and find it. So you always want to check your stipulations to make sure you have to go any farther. Sometimes you don't have to go any farther with mean value theorem. You stop because it does not apply.